So in this session, I'm going to cover how to actually calculate f-value. And again, f-value is the ratio between group variance and within group variance. And again, if between group variance goes up, then f-value goes up. If within group variance goes up, then f-value goes down. And I told you about the concept, but briefly I'm going to summarize it again. This is between group variance. How far are they from each other? And the dispersion in each subsample, when you add up together, then that's going to be within group variance. So understand that between group variance is about how far are these subsamples away from each other in light of your continuous variable. Within group variance is all about within each subsample, how are the cases away from the central tendency. So that's the concept. So, and then uh, you need a couple of information before you actually delve into the calculation of f-value. First of all, you need grand mean calculation. But this is probably the easiest one because just by looking at the original sample data set, you can calculate it. What is it? It's just simply mean of traffic tickets, mean of these values, average of these values. And again, make clear distinction between sample and subsample. This is mean of sample, and you have all these mean number of traffic tickets for each subsample. And what's interesting about this, if you use the rule of um, division and multiplication and addition and all that, as a matter of fact, mean of these three values, mean of these subsample means will give you the grand mean. Does it make sense? I hope so. So anyway, you know the grand mean and you know the subsample means. Now you're ready to engage in a f-value calculation. The first between group variance is number of first subsample times the first subsample mean minus grand mean squared plus number of cases in a second subsample times mean of second subsample minus grand mean squared plus number of third subsample times mean of third subsample minus grand mean square that. And of course, as a matter of fact, the original formula goes down to how many uh, subsamples you have, right? If you have, because of your categorical variable, if you have like 5 categories, then you're gonna come down to 5 of them. Here I'm covering just 3 because we have, in this example, we only have 3 categories. So, and this is not over. Once you're done with summing up all these between group variance, you gotta divide it by first degree of freedom, or we call that numerator degree of freedom. So please note that we use both terms for various reasons. But first, it can be said first degree of freedom, or second, you can say that numerator, because this is going to be the numerator of the f value, numerator degree of freedom. And what is it? It's as simple as just number of subsamples minus 1. And what is it in this case? It's just 2. We got 3 subsamples, so it's minus 1 is 2. And again, the distance between first subsample and grand mean, this distance, right? Square that and multiply that with the sample size. The distance between second subsample and grand mean, square that and multiply that with the sample size. Same goes here. This distance, which is here, so you square that and then multiply with the sample size. That's going to give you this numerator part of this between group variance, and don't forget to divide it with degree of freedom. So it's going to give you between group variance. Now this is a little bit more complicated within group variance. It's not really complicated to understand it, but it's just more calculation. Now what you're going to do is simple as this. For each and every case, like all of these, each and every case, you subtract the subsample mean and then square it and then add up all of them together. And you divide that number with degree of freedom for this within group variance. We call this second degree of freedom or denominator degree of freedom. So what is this about? How do you do that? Well, again, graphically, just like this. For each and every case, get the distance between this case and central tendency of that subsample. Get the distance between this case and this central tendency of this subsample. This case and its distance from the central tendency of its subsample. Square that and sum them up. You do the same thing for this subsample. Get the distance from all the cases and the distance to the central tendency. Square that. And here too, for each and every case, get the distance between that case and its central tendency. Square that and add up all together, and then add up all together. That's going to give you this numerator part of within group variance formula, and then divide it with degree of freedom. What is degree of freedom for within group variance? That's just the sample size, number of cases. In the original sample, which is actually n, the big N, which is this, the sample size minus what? Number of subsamples. That's going to give you that. So for example, you had what, 500 cases here. 500 cases minus how many subsamples do you have? How many, to be exact, how many categories in your categorical variable do you have? 3. So it's going to give you this much. And to be specific about this numerator calculation, this is like this. If your mean number of tickets for white subsample is 3 and your mean number of traffic tickets for black subsample is 2, and if your mean number of traffic tickets for Latino subsample is 5, then you subtract your subsample from each and every cases for each and every case a subsample, and then you square them, each and every of them. You square them. keep in mind that for this white subsample, for each and every case in it, you subtract uh, white subsample mean number of traffic tickets. For black subsample, from each and every cases in here, you subtract black subsample mean number of traffic tickets. So you go on like this. You square them and then you add up everything together. You can do that individually, like for this subsample, this subsample, and this subsample, or you can simply just add up all together these squared values. This is going to give you this part. As a matter of fact, here too. Yeah. And then you will get the F value. How do you do that? This between group variance divided by within group variance. So you actually calculate the F value, and then again you have to compare that with critical value using first and second degree of freedom, and of course confidence level, which is always, not necessarily always, but most of the times is 95%. And again, we call that first and second degree of freedom, or we call that numerator and denominator degree of freedom. And in this case, it was 2 and 497. So this is how you find the critical value. And again, when critical value is larger than your calculated F value, then you cannot reject the null hypothesis, and you accept the null hypothesis and say there's no difference between these subsamples in terms of number of traffic tickets. And if your calculated F value is larger than critical value, then you reject the null hypothesis and say there's difference between these subsamples. But still, the problem is you don't really know which one is higher or which one is necessarily different from each other. Meaning that, oh, as a matter of fact, you can know which one is higher and which one is lower because you got the central tendency already. So if you reject the null hypothesis, then you know that there's a difference in it. The problem is you don't know which one is significantly different from others. That's the problem. It can be either this, or it can be either this, or it can be this. So it means that it might be that white subsample is significantly different from black subsample, this 3 and 2. But turns out black subsample and Latino subsample are pretty much the same. Well, in this case, it doesn't make sense. It's 2 and 3. So probably, let's say, white subsample is pretty much the same as Latino subsample. Although you see this difference in a central tendency, again, it's not only about central tendency, it's more about dispersion, right? So you don't know which one is the case here, but at least you know there is at least one difference between two of these subsamples. That's the conclusion from F-test.